Hello students, this is a video on the topic tests that we have at Bodhee Prep. So these topic tests, the idea is that once you've done a concept and practice the concept, you can evaluate yourself through these tests. And therefore, the tests are available for each topic. So as you keep covering a topic, give tests for the topic to be sure that you're done with the topic. Once you give a test, you can refer to the related video where we try to give you a perspective of what would have been a good attempt, the solution to all the questions, and the kind of time that you should have spent on a given question. If you do like the test, there are more than 200 topic tests available on our Android app for Bodhee Prep. The link for the app is in the description of the video. Make sure to download the app and make use of these tests fully. This video is about the divisibility rules topic, and this is test number 4 in the app. Overall, the test was a moderate level of difficulty test, and about 6 to 7 questions would be a good attempt. That is 95 percentile plus. The ideal time, because a couple of questions, cases were formed, the attempt time should go up to somewhere around 20 to 23 minutes. Looking at the individual questions, if m is divisible by 420 and n is divisible by 294, then what is the largest integer which divides m plus n? Since m is divisible by 420, m will be divisible by all factors of 420 as well. Similarly, n will be divisible by all factors of 294. So what we can do is we can look at the common factor here. If we find the HCF of 420 and 294, 420 is 42 into 10, 21 into 2 into 10. I'll just stop at that for now. For 294, if we divide by 21, 2174,844. So 21 into 84. 21, 10, 210 and 4. 10 for 210 and then into 14. So 21 into 14. So this will become 21 into 2 into 7. And therefore, clearly the highest common factor for 420 and 294 will be 21 into 2, which is 42. Since m and n individual are divisible by 42, m plus n will also be divisible by 42, and therefore 42 becomes the answer. Basic application of divisibility rules, easy question, should not take more than 90 seconds to get the answer. A, B, C are non-negative integers. Non-negative integers means they can be 0 or positive integers less than 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are the options. 100A plus 10B plus C is divisible by 5. That means C is either 0 or 5, non-negative. 10A plus C is divisible by 3. Okay, so 10A plus C means A plus C, because 10A plus C will be a 2-digit number which will read AC. A plus C is a multiple of 3, could be 3, 6, 9, 12, 15, etc. 10B plus C is divisible by 4. Now 10B plus C will be a 2-digit number BC. C is either 0 or 5. Since BC is divisible by 4, C cannot be 5. So we get the value of C as 0. Again, B0 has to be divisible by 4. So B could be 0, 2, 4, 0, 20, 40, 60, 80. 10A plus B is divisible by 9. 10A plus B is divisible by 9. Okay. Now if we put A as 0 here, sorry, C as 0 here, A plus 0 is equal to, it can be 3, it can be 6, it can be 9, it cannot be more than that. And therefore A is either 3, 6 or 9. B we know is 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. 10A plus B is divisible by 9. Therefore AB or A plus B has to be a multiple of 9. So from here if we look at it, 3 plus 6 gives us 9. No other combination with 3. With 6, 0, 8, 10, 12, 14, no combination. With 9, 9 and 0. With 9, 9 and 0. This could be a combination. Find the value of ABC. So the result that we get is ABC. A could be 3, B could be 6, C is definitely 0. A could be 9, B could be 0, C could be 0. And therefore the number becomes, in this case, 360. In this case, 900. 10A plus C is divisible by 3. 30. 90 divisible by 3. 10B plus C is divisible by 4. 60. Again, 10B plus C in this case will be 0, 0, which does not make sense. So this should not be the case. Even though A plus B plus C will still be the same as the previous one. 10A plus B is divisible by 9. 36 is divisible by 9. So find the value of A plus B. A plus B plus C is 9 becomes the answer. Again, I think a moderate sort of a question. There is exactly one case that will form. So even if we hit that case without considering the other cases, that is okay. Since there are just 3 numbers and spotting C0 is not very difficult, I don't think this question should take more than 2 minutes to solve. The number j square, where j is an integer, leaves the remainder of k when divided by n. K is less than n, obviously. Only then will the remainder be k. How many possible pairs of values kn are there where n lies between 1 and 10? Now n could be 2, 3, 4, 5, 6, 7, 8, 9. Right? If we look at j, any number with 2 could be leaving a remainder of 0 or 1. With when divided by 3, any number could leave a remainder of 0, 1, 2. With 4, 0, 1, 2 or 3. With 5, the remainders could be 0, 1, 2, 3, 4. With 6, they could be 0, 1, 2, 3, 4, 5. With 7, they could be 0, 1, 2, 3, 4, 5 or 6. With 8, 0, 1, 2, 3. Basically, I'm making all cases and I'm going to directly check. 6, 7. With 9, remainders could be 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. These 6, 7, 8. These could be the remainders with 9. Now, if we look at j square, what will be the remainder when divided by n? These will be corresponding values of a. 0 square is 0, 1 square is 1. So the remainder could be 0 or 1. So we get 2 pairs, 2 comma 0, 2 comma 1. With 3, 0 square divided by 3 is 0. 1 square divided by 3 is 1. 2 square, 4 divided by 3 is the remainder of 1. So no need to write again. Again, 2 pairs. With 4, 0 square is 0. 1 square divided by 4 is 1. 2 square divided by 4 is divisible. 3 square, 9 divided by 4 is the remainder of 1. With 5, 0 square is 0. 1 square is 1. 2 square is 4 divided by 5, remainder 4. 3 square is 9. 9 by 5, remainder 4. 4 square is 16. 16 by 5, remainder 1, which is already there. With 6, 0 gives 0. 1 gives 1. 2. 2 square, 4 divided by 6 is the remainder of 4. 3 square, 9 divided by 6 is the remainder of 3. 4 square, 16 divided by 6 is the remainder of 4. 5 square, 25 divided by 6 is the remainder of 1, which is already there. With 7, 0 will give 0, 1 will give 1. 2 square, 4, remainder is 4. 3 square, 9 divided by 7, remainder is 2. 4 square, 16 divided by 7, remainder is 2. 5 square, 25 divided by 7, remainder is 4. 6 square, 36 divided by 7, remainder is 1, which is already there. With 8, 0 will give 0, 1 will give 1. 2 square, 4, remainder 4. 3 square, 9, remainder is 1. 4 square, 16, remainder is 0. 5 square, 25, remainder is 1. 6 square, 36, remainder is 4. 7 square, 49, remainder is 1. So 0, 1, 4, 3 options. With 9, 0 gives 0, 1 gives 1, 2 gives 4. 3 square, 9, remainder 0. 4 square, 16. 16 by 9, remainder 7. 5 square, 25. Again, remainder 7. 36. 9 4 is remainder 0. 49. 49 means remainder 4. 64 divided by 9, remainder 1. So 0, 1, 4, 7. So 2, 0, 2, 1, 2 pairs here. 3, 0, 3, 1, 2 pairs here. 4, 0, 4, 1, 2 pairs here. 5, 0, 5, 1, 5, 4. 3 pairs here. 6, 0, 6, 1, 6, 4, 6, 3. 4 pairs here. 7, 0, 7, 1, 7, 4, 7, 2. 4 here. 8, 0, 8, 1, 8, 4. 3 here. 9, 0, 9, 1, 9, 4, 9, 7, 4 here. 2, 2, 4, 6, 7, 8, 9, 13, 17, 20, 24. Total 24 pairs are there. Again, outright counting, The concept may not be very difficult, but the point is counting does take time, and therefore 2.5 to 3 minutes easily to solve this question. How many positive 10-digit integers have the property that all digits of n are distinct and n is divisible by 1, 1, 1, 1, 1, 1? Positive 10-digit integers. Suppose the integers are A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8, I, J. These are the 10 digits. All of them are distinct. So these digits have to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all of the 10 digits and or a combination thereof. Now this number has to be divisible by 1, 1, 1, 1. Also, we can see that the sum of digits will be 45, which means this number is also divisible by 9. And therefore, this number has to be divisible by 99999. This is what I'm working with. Now, this number can be written as A, B, C, D, E followed by 5 zeros, that is into 10 raised to power 5. 1, 2, 3, 4, 5. Plus F, G, H, I, J. If I break this down to get 9999, we'll write A, B, C, D, E into 99999. 1 lakh is split into 99,999 plus 1 plus A, B, C, D, E into 1 plus F, G, H, I, J remains as it is. And therefore, we can say in this number, this part clearly is divisible by 99999. And therefore, the remaining part A, B, C, D, E plus F, G, H, I, J. This has to be divisible by 99999 as well. So this sum could be 9999 or it could be 9999 into 2, which will be which is not possible, because for this to happen all the digits have to be 9, but the digits are different. So in any case the only sum possible is this. Now distinct digits, we need a sum of 9. How can that happen? 0, 9, 1, 8, if we add them, 2, 7, 3, 6, 4, 5. These are the cases. Now out of these cases, what is the value A can take? A is the first digit, cannot be 0. So A could be any one of the other 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. A has 9 options. Suppose we put A as 8. By default, F has to be the remaining one, 1, so that 8 plus 1 becomes 9. So 1 and 8 is taken, for example. How many options does B have now? B can take any one of the values, 1, 2, 3, 4, 5, 6, 7, 8. Suppose B takes 9. By default, to get the sum 9, G has to be 0. How many options does C has now? There are 6 options left. C could be any one of the 6 numbers. Suppose C becomes 5. By default, H has to be 4, so that 5 plus 4 is 9. Options left for D are 4, could be any one of 2, 7, 3, 6. Suppose D becomes 7. I by default has to be 2, so that 7 plus 2 is 9. And for E, therefore, there are 2 options left, either 3 or 6. Say 3, J has to be 6. So the total number of combinations will be 9 into 8 into 6 into 4 into 2, which becomes 72. 72 into 6 will into 6 into 8. 72 into 6 is 420, 432 into 8. 8 to the 16, 6, carry forward 1, 7, 24, 5. 8 and 24, 1, 5, 2. 8 for the 32, 31. 3, 4, 5, 6. How many 10-digit numbers are there? 3, 4, 5, 6 becomes the answer. Again, this is not a question that I would want to pick up in an examination for the first time. If I have an exact idea of what I'm going to do, maybe pick it up. Otherwise, this is not a question that will be cracked for the first time in an exam. What is the largest integer value of n such that 8n divides 100 factorial evenly? Now, in 100 factorial, if we look at the highest power of 2, we will start dividing this by 2. 50, 50 by 2. Now, this is a standard format of finding highest power of a prime dividing a factorial. Divide the number for which the factorial is being calculated by the prime that is being checked. Keep dividing successively until we and write only the integral part. So 100 by 2 is 50, then divide 50 by 2, 25. 25 by 2 is divisible 12 times. 12 by 2 is 6. 6 by 2 is 3. 3 by 2 is divisible only once. The moment the remainder is less than the divisor, stop. Add all of these values 75, 87, 97. And therefore, we can say 100 factorial is 2 raised to power 97 into some other value, say b. This b will comprise of 3s, 5s, 7s, etc. Now, what is the largest integer value of n? Such that 8 raised to power n divides 100 factorial. So we need to form 8s here. 2 cube is 8. 97 is not divisible by 3. So we make it divisible by 3. We say 2 into 96 into 2 into b. Take the 3 common from here. So 32 into 2 into b. So this becomes 8 raised to power 32 into 2 into b is 100 factorial. What is the highest power of 8 that will divide 100 factorial? This division can happen 32 times, and therefore the highest power of n or highest value of n is 32 becomes the answer. So direct application of factorials and division. So it's an easy question. Should be done in less than 90 seconds. Given that x plus 4y is divisible by 5, x plus 4y is divisible by 5, which of the following expression is necessarily divisible by 5? Okay, x plus 4y is divisible by 5. We can also see that 5x plus 5y will be divisible by 5 because both are multiples of 5. If we add them, 6x plus 9y will be divisible by 5. Option C becomes the answer. So basically, if you have a number, just keep adding or subtracting multiples of 5 thereof. So since here we had x and y, to x plus 4y, I'm adding 5x plus 5y to get 6x plus 9y. Again, once this strikes, it's a very simple concept. The question will be solved in seconds. Otherwise, we'll have to work with options where we take the difference, right, one by one. And from there, we'll be able to see that here the difference is 5x and 5y, which will eventually give us the answer. But again, something that can be done in the exam. Even if we start putting values, we should be able to get the answer. For example, if we put x and y as 1 and 1, so we see that 1 plus 1, 5 is divisible by 5. Now put the same value here. 3 plus 1, 4, not divisible by 5. 7 plus 6, not divisible by 5. 6 plus 9, 15, divisible by 5. 2 plus 5, not divisible by 5. So if we put x is equal to 1, y is equal to 1, even then we'll get our answer. But again, should be open to attempting this question. How many positive integers less than 1500 are divisible by 7 or 11, but not by both? Okay. So the smallest number divisible by 7 is 7 into 1. The largest number will be 7 twos are 14, 200 and 20, 298. So if we say 7 into 214, this will be 1498, 1498. So positive integers less than 1500 divisible by 7 are 214 in number. With 11, 11 into 1 is 11. Maximum number will be 11. 11 ones are 11, 40. 11 threes are 33, 70, 136. 11 into 136 will give us 1496. So 136 numbers here. Now from here we subtract the numbers which will be common to both of them. So 77. Divisible by both 7 and 11. 77 into 1 is 77. The highest number will be 77 into 20 will be 1540, which will cross 1500. So 77 into 19, whatever the value is, would be less than 1500. I don't need to calculate it, but I'm still doing it. 77 into 20 was 1540 minus 77. So 1500 minus 37, 1463. 19 such numbers. So what I'm saying is, out of these 214 numbers, these 19 are included. So let us first subtract them. We get 195. These are numbers which are divisible by 7 and not by 11. Similarly, in these 136, these 19 are included. So 136 minus 19. 136 minus 19 becomes 17, 117. These 117 are numbers which are divisible by 11 but not by 7. If we add these two, we will get numbers 5, 3, 1, 2. 3, 1, 2 numbers which are divisible by 7 or 11, but not both. And this becomes my answer. Again, easy concept, not very difficult calculation. So it's about 2 minutes, but we'll classify this question as easy. A six-digit number is the maximum possible number such that the number formed by the three digits at the right side. 1, 2, 3, 4, 5, 6. Right side. These three is twice the number formed by the three digit left side. If this is ABC, this will be 2ABC, something like this. For example, if I say 1, 2, 3, 4, 5, 6, if this is 1, 2, 3, this will be double of this, that is 2, 4, 6. 1, 2, 3, 2, 4, 6. The six-digit number must be divisible by. Again, just divide 1, 2, 3, 2, 4, 6 by each of them to get the answer. Or the other approach could be the first three numbers value will be ABC into 100. 1000, but basically this is nothing but 123,000 plus 246. So this can be written as ABC into 1000. This can be written as ABC into 2. So the total value will be nothing but ABC into 1002. Now ABC could take any values, but 1002 is a part of this number for sure. If we start factorizing 1002, this will be 501 divided by 3. 3 ones are 3, 20, 6 are 8, 167. So 1002 is 2 into 3 into 167. And therefore, from the options, has to be divisible by 167 for sure. Again, assuming a value and then checking using the calculator in the exam will still give you the answer. But if you're able to get the method better, so yeah, moderate level of difficulty should not take maybe 2.5 minutes to solve, no matter what process you follow. What is the sum of all positive integers n for which n cube plus 7n square minus 13n plus 19 is divisible by n minus 4? If we divide the polynomial n cube plus 7n square minus 13n plus 19 by n minus 4, some part of this will be divisible, we'll get a quotient, and there will be some remainder. To find the remainder, we can use the remainder theorem. So from n minus 4, we put n minus 4 is equal to 0, n is equal to 4, put that value of 4 in the polynomial. So the remainder will be 4 cube plus 7 4 square minus 13 into 4 plus 19. Put the divisor is equal to 0, get the value of n, substitute that in the numerator. 64, 16 into 7, 112 minus 52 plus 19. 112 minus 52 is 60, 60 plus 64 is 124, 124 plus 19 is 143. Now, if this polynomial is divisible by n minus 4, there should be no remainder. That means the remainder should also be divisible by n minus 4. Remainder is 143. 143 should be divisible by n minus 4. 143 is nothing but 11 into 30. So as long as n minus 4 is a factor of 143, the division will happen. The factors of 143 are 1, 11, 13 and 143. These could be values of n minus 4. So when n minus 4 is equal to 1, n will be equal to 5. N will be equal to 11 plus 4, 15, 13 plus 4, 17, 143 plus 4, 147. What is the sum of all positive integers n for which this is happening? So if we take the sum 147 plus 17, 164 plus 20, 184 becomes the sum of all positive numbers, and that will be the answer. Again, a couple of concepts involved, namely factor theorem, remainder theorem, then breaking the number into factors and then counting cases. So I'd say moderate level of difficulty, about 150 seconds to solve the question. Which one of the following numbers represented in base 8 is divisible by 7? So when we are looking at a smaller base, the remainder is simply the sum of digits. So here, if we divide by 7, the remainders will be 4 plus 3, 7 plus 2, 9 plus 1, 10. Here it will be 5 plus 4, 9 plus 3, 12 plus 2, 14. 14 is divisible by 7. So this will be divisible by 7. The logic being, this number can be written as, or a number A, B, C, D in base 8 will have a value of 8 cube into A plus 8 square into B plus 8 into C plus D. when this is divided by 7. 8 cube divided by 7 gives us a remainder of 1. So from here the remainder will be A. 64 divided by 7 is a remainder of 1. So from here the remainder will be B. 8 divided by 7 is a remainder of 1. So from here the remainder will be C. And D is as it is. So when any number of this form is divided by a number 1 less than the base, the remainder simply is the sum of the digits. Now if we want the number to be divisible by 7, the sum of digits should be divisible by 7. Here the sum of digits is 4, 3, 7, 8, 9, 10, not divisible by 7. 5 plus 4, 9, 12 plus 2, 14, divisible by 7. 6, 4, 10, 15, 18, not divisible by 7. 7, 6, 4, 10, 15, 7, 22, not divisible by 7. The only possibility is when the sum of digits is 14, which is divisible by 7, and therefore the number will be divisible by 7 as well. Right? So option B becomes the answer. Again, if you have done a question earlier like this, it's a direct application of that concept. If you have not done it, then I think would be a moderate level of difficulty. But someone who's finished the concept of a number system should be able to do this without too much of a problem. Now, looking at the overall level of difficulty of this paper again, as I said initially, a moderate level of difficulty, 6 to 7 questions would happen. If I had to choose my questions, the 7 questions, they would be 1, 2, 5, 6, 7, 8, 10. Which are these? Would have done this every single time, just finding the common factor. This also is putting values and solving, not very difficult. This, I think, counting cases was there and could get lengthy, so might have left it. This, I think, was a good question, not something that I would do in an exam outrightly. This was a straightforward application. Again, this was easy, just adding 5x plus 5y. Here, there is a scope for confusion, but I think by now you would have done many questions like this, which could have been attempted in the exam as well. This I thought was a simple question. All you have to do is put in the values and check. This I think was a better question unless you know the factor theorem and what to do with the remainder. You might not be able to do this. This again was an application of the formula that would have done by now. And therefore, for me, I would have left 3, 4, and 9. The rest of the questions I would have attempted in the paper.